Hey there, year sevens. Today we're going to be talking about compound probability. So when we say something is undergoing compound probability, think of joining two things together, or more than one things are being combined together. So they're being compounded or joined together. When we talk about compound probability, you can think of looking at dice where something is an odd number and it's less than 3. So that would be an example of compound probability because there's two different things we're combining together, that it's an odd number and that it's less than 3. So that's what we mean by compound probability. Sometimes with compound probability problems, we use things like decks of cards. So here's an example of a standard deck of cards right here. So just a couple quick things. So you have 4 suits with a deck of cards. So you probably are familiar with this. You have diamonds, clubs, hearts, and spades. Those are the 4 suits. I found out just in talking with a colleague that these are known as picture cards. In Australia, we call them face cards at home. You got the jack, the queen, the king, and you got 3 picture cards or face cards per suit. Generally speaking, you have two overall colors. You got red, black suits or colors. And after that, in each one of your suits, there's about 13 cards. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There's your cards. So just a quick kind of tour of a deck of cards. We'll be using that coming up in a second. When we talk about compound events, pay attention to wording. Sometimes you might hear wording such as at least or more than. They may seem very simple, but or very similar, but they're not. So if you have, if I say, at least 4, that's, the minimum number, whereas more than is going to be anything above a certain number. So make sure you be careful with those. And simple words like and, or not really are words that really help you give clues to what you're trying to find the probability of. Let's get into it. So back to our deck of cards. One card is chosen randomly from a standard deck of cards. What is the probability that it's red? So for A, if I was trying to determine the probability of something being red, notice I'm using my P brackets, and then what I'm trying to determine the probability of, P of red, well, I go back and I look at my deck of cards. I can erase some of my writing that I just put up there just to kind of make it a little bit neater, a little bit easier to read. So what is the probability of something being red? Well, you could set and count it out. So you know that's 13 and 13 of your cards. So we know of the total deck there's 52 cards, and I know that 13 are hearts and 13 are diamonds, so 13 plus 13 makes 26. You can also look at it as this way. If you have, you can also visualize that this is half the deck. So half the deck is red, half the deck is black. And if you simplify this fraction down, if you divide both the top and the bottom by 26, you will get it to be simplified to 1/2. So there's a probability of something being red. What's the probability of something being not red? So the probability of not red, the complement of a red card. Well, again, you can go back, and you know that if half is red, you know the other half is going to be black. So again, that's going to be half. C, what's the probability of it being a club? So the probability of a club. So you can take a second and look at your deck, and you know that your clubs are these ones right here, and that would be 13 clubs in a deck. So I counted that out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 is how I kind of knew that, if you're not sure. So the probability of something being club is 13 out of 52. But if you also visually look at it, you also know that that is 1/4 of the deck. So 1/4 of the whole entire deck is clubs. If you look at it, you know you got 4 quarters, and one of those 4 quarters, and if you take 13 divided by 13, it's 1. And if you take 52 and divided by 13, it's going to be 4. And that's the probability of something being a club. So D. I'm going to run out of room really quick here. So D, so we got that one done. So this was 1. I won't even, I'll just keep it. It's going to get really messy here fast. Okay. So D, I'll try not a club and see if I can get D to fit in here. So the probability of not a club, well, we can go back. Sorry, I would draw this up above, but I've kind of run out of room. So we can flip back, and if 1/4 is a club, that means that 3/4 would be indeed a club. If you wanted to, you could count it out, and you could find that I think it's about 39 of the 52 cards is equivalent to 3/4. So if I go back, I can say 3/4. If you also said 39 out of 52, that's also correct, because if you divide 39 by 30, how do I reduce that one down? Oh boy, if you also said 39 out of 52, that is perfectly fine. I think you can start dividing it down. I think 39 can be divided by 3. You can kind of start simplifying it down and just keep simplifying it down each time. I'm fairly sure 52 is divisible by 3. Nope, it's not. So what I would do is I'd kind of work at it. Let me just think of how I would do this. Oh, I got it now. Sorry about that. I just had to take a second. I believe that you can take 52 divided by 13. So if you divide that by 13 and divide this by 13, divide both these by 13, it simplifies out to 3/4. Sorry about that. I had a brain fart for a second. So that would be the probability. I'm going to erase this all away so I can keep going. So we've got not a club done. A 7. So give me a second. Let me erase things out here. So I'm just going to grab my eraser. Just make my eraser bigger. There we go. So let's get to E. So a 7. So let's go back. My 7s are all right here. So my total deck, that would be 4 out of 52. I know both those are even numbers, so I can simplify that down by dividing each by 2. 4 divided by 2 is 2. 52 divided by 2 is, I just got a crazy answer. 52 divided by 2 is 26. Those are still both even numbers, so I can even simplify it again. Divided by 2 again, and divided by 2 again. I got 1 out of 13, I believe. 1 out of 13 is a 7. So you could have said for this one, the probability of a 7 would be 4 out of 52. Or you could have said the probability of a 7 is 1 out of 13. So F, neither a 7 nor an 8. So it can be neither of those two. So I'm going to take a second and I'm going to erase just so we kind of can visualize that out, because I do like having this out to visualize and it helps us out. So what this question is saying is it's neither a 7, 2, 3, 4, 5, 6, it's neither 7, so it's not these two. So it is not these two. And so one way to easily count this out is what you can do is you can count by 4. So 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44. So that would be, to erase. I just skip counted to get 44. The other way you could have done this easily is gone 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 groups of 1, 2, 3, 4. And so you know that 11 times 4 would equal to 44. Another way to get to the same answer. So 44 of the 52 cards would be not a 7 nor an 8. So again, we'd want to simplify that down. You want to make sure that you're getting it to the lowest term. And if you said this would be fine, but it is also equal to, I'll start by dividing by, I bet you can divide by 4. I'll bet you can divide 44 by 4. So if I divide 44 by 4, I get 11. And if I divide 52, just give me a second, if I divide 52 by 4, I get 13. So again, simplified, 11 out of 13 probability or chances. This is pretty good chances that you're going to get not 7 or 8. So your probability of not a 7 nor, I've run out of room. Let me erase. Don't need that stuff there anyways. Probability of a 7 nor an 8. Nor an 8 would be out of 52. We established that would be 44 to 52, which is also equal to 11 out of 13. All right, a red ace. All right, how many red aces you got? 1, 2. Pretty simple. There's no other red aces, so a red ace. For G, the probability of a red ace is going to be 2 out of 52, which can be simplified to 1 out of 26 chances. Not very great chances, but hey, there's still chances. A red card or an ace. So there's two possibilities that we're going to go for here. So for H, we are going to find the probability of a red card or an ace. So let me clean up things in our previous slide just so we can easily kind of visualize this. So what we're going to be getting here, oops, I want my eraser. Yeah, okay, good. So we want a red card or an ace. So number one is going to be a combined. So it's going to be aces and the red cards. So you can't double count in these situations. So one way to do this, and you got to be smart and careful when you do this, is don't double count your aces when you're doing this. So I'm going to first count like this, and then I'm going to count like this, and then I'll count my last two aces, okay? So I know this is 13, plus another 13, plus the two remaining black aces. I don't have to recount these two aces because you do not need to double count them. You just go plus 2. So that's going to be 26, or plus 2 is 28. So that'll be 28 out of 52. Let me erase my rough work or my working out. I can now start to simplify that fraction down. 28 out of 52, 28 divided by 2 is 14. 52 divided by 2 is 26. Let's reduce that one more time. I'll divide them each by 2, divide by 2, and that's going to give me, let me erase my other working out. Sorry about that. Divide by 2. 14 divided by 2 is 7. 26 divided by 2 is 13. So there's our probability right there. So I'll state that it's 28 out of 52 or 7 out of 13, okay? So it was 28 out of 52 or 7 out of 13, I believe we had said. Yep, perfect. Okay, good. So that was a red card or an ace. A red card that is not an ace. So for I, a red card that is not an ace. So let me erase. So again, very helpful to kind of visualize this out. I don't love kind of just talking about it hypothetically. I love to visualize these out. Make sure just to kind of be able to see it. So it's going to be all these guys, but not an ace, not that guy. These red cards, including the face or picture cards, but not that card there. So it's going to be 12 plus 12 is 24 of the 52 total cards. So again, 24 out of 52, we can divide the 24 by 2 to get 12. And we can divide 52 by 2 to get 26. We can simplify that further to be 6 out of 13. Sorry about that. So your original, you can say, is it's 24 to 52 chances, or it's 6 out of 13 chances. So probability, let me erase. I've run out of room. Let me erase E. Write out I nice and neat there for you. We're trying to find the probability of a red card not an ace bracket equals So for that one, it was, I've already forgotten since we're racing, right? It was 24 out of 52, which is also equivalent to 6 out of 13. So I hope that makes sense. If I believe you divide 24 by 4 and you divide 52 by 4, that's how you get to these, if you're wondering. All right, so hope you're all doing well, and I hope that helps you look at compound probability. I hope you're all taking care, and have a good evening, or good day. It's good night here. Anyways, bye.